want to take a shot at explaining this in a different way, maybe a way that will get you to the graph a little bit simpler. If we look at the right-hand side of this V, of this graph, we'll notice that the slope is 1 over 1. We rise 1, run 1. Well, that matches up with the A in the formula. So y equals absolute value of x, that's the same as absolute value of 1x, or I should say 1 times the absolute value of x. 1 as a fraction, so A here is 1. 1 as a fraction would be 1 over 1. So you can treat that as the slope of the right side. Now, it's not the slope of the left side, but it's the slope of the right side. I should have written 1 over 1. Slope of the right side, or to the right of the vertex. All right, so rather than going through and picking x values and putting them in, another way to do it would be to find the vertex and then use your slope to find other points on the right side of the vertex, and then reflect those points across that axis of symmetry. Again, you can treat the A as the slope of the right-hand side of the vertex, right side of the vertex. All right, so let's look at this one. We've got to pick out our vertex. We don't have anything with the x inside of the absolute value, so the h is 0, k is -1. So put a point at 0, -1. That is your vertex, so your axis symmetry will go through that. Now, to the right of that, we're going to use our slope of the right side. The A here is 1, as a fraction, 1 over 1. So we'll go up 1 to the right 1. And we'll do that a couple times. And then we'll reflect those, and then we'll connect them to form our graph. Find the vertex here. Again, we see a minus in the formula, so our vertex here is -2. We don't see a k, so it's 0. Draw your axis symmetry going through the vertex. The A again is 1. We'll see that a lot on these absolute value equations. So slope of the right-hand side is 1 over 1, so we'll go up 1 to the right 1, reflect those points across the axis symmetry, and connect them to form your V. Minus in the formula, so our h here is 1. K is 2. So put a point at 1, 2. Draw your axis symmetry. The A again is 1 as a fraction, 1 over 1. So go up 1 to the right 1, plot those points, and then we'll reflect those across that axis symmetry. This time our slope, we don't see a number with the x inside of the absolute value, so that's 0. And then our k is -3. Plot a point at 0, -3. Draw your axis symmetry going through it. This time our slope of the right side is 2, or is a fraction 2/1. So go up 2 to the right 1. So then reflect that. On this one, our slope, or excuse me, our vertex is 0, 0. So put a point at the origin, draw your axis symmetry. Slope of the right side, -1/3. Now we need to go right, so the negative needs to go with the 1. Not the 3, since we're using this as the slope of the right side. So we're going to go down 1 to the right 3. Now on this particular graph, there's not enough room for any more integer points on the right side, but if we reflect that, we see the point -3, -1. Connect those and we'll have our V shape. Notice that since A was negative, it opened up down. And because that was a fraction, something that was smaller than 1, then it's wider than the ones that we've graphed so far. All right, vertex. Once you get the hang of this, feel free to pause it and try them again, and then play and see if you got it right. Vertex 0, 2. Axis is symmetry. Slope of the right side, A is 1 as a fraction, 1/1. Go up 1 to the right 1. And then you can reflect those across that axis symmetry. Vertex, -1, -3. Again, the H is opposite of what you see in the equation because the minus is already there in the formula. So -1, -3 is our vertex. Draw the axis symmetry. Slope of the right side, the A, is 1/1, so we'll go up 1 to the right 1, reflect those points across the axis symmetry, and then we'll connect them. Nine. Vertex 0, 0. Plot a point at the origin. Slope of the right side, 1/2. So from that vertex, go up 1 to the right 2. You can also go up or reflect those across the axis symmetry. Number 10 says without graphing, find the vertex. So we'll go through that real quick. Vertex on A would be 0, 0. Vertex on B, -5, -1. Vertex on C, 0, -3. Vertex on D, 2, -6. Remember, it's the opposite of what you see. And then the vertex on part E, -1, 7. State whether it opens up or down. If A is positive, it opens up. So all of these will open up except for part C, which opens down because A is negative. All right, and then to decide whether it's wider or narrower, it's going to be narrower if the absolute value of A is greater than 1. So on part A, it's 3, so it's going to be narrower, or we could say steeper, which connects with that idea of slope. If it's 1, then it's the same. So on B, we have 1, that's the same. Absolute value of -4 is 4, that's greater than 1, so it's going to be narrower. The negative makes it open down, but it's going to be narrower than y equals absolute value of x. Part D, the A is less than 1, the absolute value of A is less than 1, so that produces something that's wider, or we could say less steep. And then part E, A is 1 again, so it's the same. So again, wider, you could say less steep. And narrower, we could say steeper. Or more steep. So I hope you like this method, especially if you're struggling with the other method.